Hello everyone, myself Rupali Shevare from MVP KBT College of Engineering, Department of Computer Engineering, Nasik. Today we are going to discuss about the fourth unit of Digital Electronics Logic Design subject. So these are the course objective of this subject. These are course outcomes. Today we are going to discuss about the fourth unit, that is Algorithmic State Machines and Programmable Logic Devices. So in ASM and PLDs, we are going to study the finite state machines and ASM as well as we are going to study the notations, construction of ASM charts and realization of sequential circuits with the help of these ASM notations. And also we are going to study the PLDs. There are different types of PLDs, PLA, PAL, and we can design the combinational circuit with the help of these different types of PLDs. ASM. What is ASM? ASM is the algorithmic state machine. So it is similar to the conventional flow chart but interpreted in different manner. Basically, ASM chart is designed for the hardware algorithms. It is a graphical view, and ASM chart is basically used with the different timing relationships. It is useful to design the hardware of sequential circuits as per the specifications. It is suitable for the describing the sequential circuits. There are different types of chart notations used in the ASM chart. So first one is the state box, second one is the decision box, third one is the conditional box. What is the state box? State box is used for indicating the state of the controller in control sequence. The shape of the state box is rectangular. Inside the box we write the information such as register operations or output value we can write in the state box. For each states there are the two entries. One is for entry and another is for exit path. This is the symbolic diagram for the state box. So this entry point is entry point and this is exit point. So rectangular shape indicates that is the state box, and each state box has state name and binary code. Means we can assign the state name, anything we can assign as a state name like S0, S1, S2, S3 like this way, and we can write the binary equivalent code for that particular states. If there are 4 states, we can write the binary sequence like 0, 0, 0, 1, 1, 0, 1, 1. So this is the symbolic diagram for the state box. And next is the example of state box, how we can write the information inside the state box. So entry point is there and we write the state name here. Q1 is the state name. State name may be anything. And binary code is the 0, 0 for this state. And output we write inside the state box, and this is the exit path. Next is decision box. What is the decision box? The decision box is a diamond-shaped box. It has 2 or more exit paths. This is the symbolic diagram for the this decision box. So this state box or decision box are very useful in the ASM chart. So after the state box, the path is going to the decision box, and after the state, what decision will be taken according to the conditions. So that will be decided after the decision box. A decision box may be conditions on a signal or test of some kind of informations. See, this state box has again, this decision box has again exit path, and it will check the 2 conditions. If the condition is true, it will go to the another path. If condition is false, it will go to the another path. So this is the symbolic diagram for the decision box. So this diamond shaped box indicates that the decision box, this is the example. If that value is true, it will go to the true conditions, and if it is false, it will go to the false condition and execute that particular states. Next is conditional box. It is a oval shaped box, and in oval shaped box the input part to be conditional box must came from the one of the exit path of the decision box. So this is like oval shaped box, and conditional outputs or actions to be taken in according to that particular conditions. So this is the example of ASM chart, how the entry point is given there. So this is the state name and binary equivalent code for the given state name. And again it has 2 values, either true or false. According to this true conditions, it will execute that particular state, and false condition, then it will execute that states and go to the exit path. So what is the difference between the state box, decision box and condition box? Basically the state box is used for indicating the state of the controller in the control sequence. And decision box describe the effect of an input on the control. And conditional box, its rounded corner are different from the state box. So just you have to remember that each particular symbol is different. So for state box you have to use the rectangular shape, for decision box use the diamond shape, and for conditional box use the oval shape like of symbol. So in rectangular shape you can write the information inside the box. You can write the state name, binary code, and entry and exit path will be there. And in decision box it is a diamond shape box, and this is oval shape box. So when the information is written in this state box, the output value, it will check whether the condition is satisfied or not, and after that it moves to the exit path. In decision box it has two values, either true or false. So it has this suppose two exit paths. So if one condition will satisfy, then it will execute that particular state, and if the condition is not satisfied, it will execute the false statement. And for the conditional box, if the similar conventional flowchart is given, the conditional outputs will be considered as per the given conditions. Next is the ASM chart for the given diagram. So any combinational circuit example we can solve, and we can execute that particular statement, and we can draw that particular ASM chart. Just you have to look at the problem statement very carefully, then you can write down that particular state table, and after that you can draw the ASM chart. See, this is the ASM chart for the given problem statement. Already we discussed this in theory also, how we can draw the ASM chart. Just we have to decide how many states will be there for the particular problem statements, and if the condition is satisfied, you have to use the decision box, and according to that the statements will be shown here. Suppose draw an ASM chart for the 2-bit binary counter having enable line input E, such as E is equal to 1 when counting is enabled, and when E is equal to 0, the state will be hold itself on, that is the present state. So when E is equal to 1, that time the counting is enabled for the 2-bit binary counter, and when E is equal to 0, that time it holds the self state. That is the problem statement. So we can draw the particular ASM chart for the given problem statements. It's very easy. So these are the example we have to solve. Okay. Already we have solved these examples in the theory lectures also. You can go through that PPTs, and you can go through that videos also for detailed informations. Next is mux controller method. It is used for the realization of combinational circuit for any controller. So in this method, the gates and the flip-flops are placed by the mux and resistors. These 3 levels of components are there: mux, resistors, and decoder. So what is the mux? Mux determine the next state of the resistors, and resistor is nothing but the group of bits. It holds the group of bit information, because see, flip-flop holds only 1 bit data at a time, and it is 1 bit memory cell. But resistor can hold the n number of bits, and when you want to store the n number of bit information, you can use the resistors. And decoder means what? It provides a separate output for each control state. Sometimes combinational circuit is used in many places of decoder. So that time we can use the concept of decoder. So this is the state transition table. In state transition table, first column holds the present state, next column holds the next state, and last one is the excitation table. So serially, when the present state are given there, we have to verify that when present input state is 0, 0, what will be the next state? It will be 0, 1. When present state is 0, 1, and what will be the next state? It will be 1, 0. When present state is 1, 0, what will be the next state? It is 1, 1. And when present state is 1, 1, the next state will be 0, 0. So as per this, we can find out the excitation table when the present state is 0 and next state is 0 for the S0 input. So what will be the excitation table entries? So according to that, we can find out D0 and D1. So this is the logic circuit diagram. So here the 4:1, that is nothing but the cascading. So when more than one multiplexers are used, that is nothing but the cascading. So you can use the cascading also. This is the state transition table. Next topic, that is the programmable logic devices. In programmable logic devices, there are different types of PLDs we are going to study, that is PAL, PLA, etc. Okay, so there are again FPGA, that is the field programmable gate array, CPLD, that is complex programmable logic devices. So there are n number of PLDs devices. We can use that devices when we are designing the combinational or sequential circuits. So discuss these various types of ICs when we are performing the digital operations such as mux, demux, adder, comparator, code converter, shift registers or counter. So that time we need to use the AND array or OR array. So we required again the fixed function ICs when we are designing the PLD. So that's why the designer can select the ICs for the designing of this different type of combinational circuit. So what are the advantages of these methods? So low development cost, fast design and easy to test. That is the main advantage of this PLD. Next is disadvantages. So it required again the large board space, large power requirement, lack of security, additional cost, space and power requirement when we modify the circuit. So what is the ASICs? That is, ASICs is nothing but the application specific integrated circuits, that is the ASICs have been developed. So to overcome all the previous drawbacks, we use the ASICs. What are the advantages of that? That is the reduce the space requirement, reduce power requirement. If produce the large cost, then we can reduce the cost also. So reduction in the size due to the high level of integration. And design is so much difficult when we are using the n number of ICs. The circuit complexity get increased, and when we want to reduce that circuit complexity, we can use the ASICs. So what are the disadvantages? The testing method may have to be developed, which maybe increases the cost as well as efforts. So PLD is an IC that is used for configurable and capable of implementing logic functions. So VLSI is a very large scale integration chip which allows the designer to customize any specific applications programmed by the user. PLD have the following advantages with the fixed function ICs, that is short design cycle, low development cost, and there are different advantages over the fixed function ICs. First one is the reduction in the board space, the reduction in the power requirement, design security, compact circuitry or higher switching speed. So with the help of regular ICs or that it will increase the complexity, so that can be easily reduced with the help of this fixed function ICs. So these are the advantages over the ASICs, that is high density, lower quantity production cost, reduction in board space, reduction in power requirement, and reduction in again board space also, design security. So these are the advantages of this ASICs or this ASICs fixed function ICs. Why we are using PLDs? Because designers are having more flexibility to experiment with the design. So it can be reprogrammed in seconds, and design modifications carried out in short time of period. So that's why the large number of PLDs have been produced by the ICs manufacturer with a variety of flexibility and options. So now we'll solve the examples on combinational circuits, how we can implement that combinational circuit with the help of PLD. So we can use the different AND array or array concept. So we first of all we will discuss the input buffer, output buffer symbols, and how that buffer symbols can be used when we are designing the PLD circuits. So already we had taken the Mentimeter test quiz on this topics. So this is just overview of this quiz. So these are the references. So thank you everyone.